Welcome to solving a problem using a sinusoidal model. In this particular example, we are looking at the Singapore Flyer, which is the largest Ferris wheel in the world, and the table of values to the left here shows the height of a rider from the ground at different times. Now we're going to be talking about two friends here, Geordie, who got to go on the flyer, and Yale, who was in the building directly opposite from the flyer, and he's standing at a height of 400 feet. This becomes important later in our question. I have entered the data into my calculator, as you can see here. And now I'm just going to and I've also changed my window. So I'm going to take a quick look at my graph, just the stat plot, and I can see from the dots that I have a sinusoidal function happening here. So now it's simply a matter of doing the regression, which we've done before, but I'll review here. So stat, over to calc. I'm going to go up because it's shorter to get to sine reg from the bottom. It's C, enter, and then second, 1, which gets me L1, comma, second 2, comma, varse, over to y varse because I want my function, hit enter, and I'm just going to be happy to set it into y1, enter, and enter. Now it calculates for me. And here I have my values. And here's our equation written out from the calculator. I've shortened it down to 4 decimal places for each of my numbers that are not whole numbers. So when we look at this equation, we can quickly look and go, all right, the amplitude is 246. And the sinusoidal axis is 295, and that tells us a little bit about our graph. We can add up the 246 and the 295, and we should get our maximum that we can see from our table of values at 541. And the 295 also tells us that the hub of our Ferris wheel is at 295 feet above the ground. So now looking at this on our graph, there's our dots, and here's our graph with the line going through our dots. And you can see that all of our dots are solid, meaning that our graph fits perfectly through the points from the example. So this line of regression is a very close fit. Now you can also see I've put a line through this here, and that line matches up with our friend who's up in the building, Yale, at 400 feet. Because the question asks, when was Geordie level with Yale? So I've put in my line, and I want to know my times. When is Geordie level with Yale? And we can see here that in what my graph shows, there are 6 points at when the boys are level with each other. So now we just have to figure out what those points are. And so the way to do that is to find this point of intersection. That's why I actually drew in the line. I want to know what is my x value when my y value is 400. What is my x value when my y value is 400? And then once I have that, I can proceed on to find the rest of them. I've brought my calculator back so I can actually find those points rather than just looking at the drawing. And so as a reminder of how to find that point of intersection, we're going to go second calc, and I want number 5 here, the point of intersection. Enter, and it asks me for first curve, and my cursor, I'm going to just move so I can find it. I want it a little, there we are. I wanted it very close on the curve to the point of intersection. I'm looking for where it intersects with the line, and I'm going to get it very close and then hit enter, and now it asks me for my second curve, and I'm happy with where it has popped in on this one. It's very close to the point of intersection. Enter, and again we don't guess, so enter again, and so this point of intersection is 11.8, so 11.8 minutes when y equals 400. So I'm going to write that in. My calculator will disappear. Bringing back the calculator, I'm going to repeat that process for the next 2 points of intersection. I'll pause while I do that. So here I have my drawing again with 3 values in. So you can see in addition to the 11.8, I now have 25.2 and 48.8. When I look here at these 2 values, note that they are both in the same spot on my curve. Starting from that point, we're going up, then down, coming back up. From the 48.8, I would start again going up and down. So that, remember, is my period. So 48.8 minus 11.8 will give me my period. And because we are working our time in minutes, I know my period then is in minutes. 48 minus 11, 37. That would then allow me to calculate my next one. I don't actually have to make my calculator do the work. I can simply add 37 to the 25.2 and find my next point of intersection. And if my mental math is working for me today, that point will be 62.2. And we can continue on this pattern of finding the number of the times when the 2 boys are level, one in the building, one on the Ferris wheel. In sometimes we want to know the generic. What would be the 2 times that this would happen? And the way we would write that then is picking the first one, 11.8, so the first time he's on his upward trip on the Ferris wheel, and all of the times that he's on his upward piece of the Ferris wheel ride are going to be every 37 minutes after. And then the second part, when he's on his way down, pick the first time he's on his way down, and then plus the 37 each time. And I've put n in to represent the number of revolutions, the number of times that he goes around on the Ferris wheel and the 2 boys become level with each other. So the n then would be part of the integer numbering system, which is, I've noted it I there, but really should be as z. That's what we've been following this year. All right, so part of the integers, and so there is all of the times when the 2 boys would be level at the 400-foot mark. That's using regression to find an equation and then to answer a question. Good luck with the remainder of the questions.